Here we are in section 5-4, exercises 31 through 36. We're just supposed to be factoring, which means we can follow anywhere on this tree and get the right method with the right problem. So here we have x cubed minus 125. First question is, do we have a greatest common factor? We don't. How many terms? 2. So we're looking for a difference of squares or a sum or difference of cubes. There's a different sign, subtraction right there, but this is not a perfect square, it is a cube. So we are a difference of cubes. This is x cubed and this is 5 cubed. So that means with a difference, the pattern will be that it's x minus 5. And then the other component will be an x squared to make an x cubed. A plus 25 over here will make a minus 125. And the magic middle that will cause all of the middle terms to cancel when we multiply them out is the opposite sign, plus 5x. And you might be tempted with this difference of cubes. You should be tempted to see if this x squared plus 5x plus 25 factors. Think of what times is to 25 and adds to 5, and there isn't one. It's tempting every time, but the difference of cubes, that factor over there, is not in general factorable. All right, number 32. We have x squared minus 9x plus 18. Do we have a greatest common factor? No. So we've got to find, let me see, 3 terms. Leading coefficient is equal to 1, so we are a nice easy one here with an x and an x. And then we've got to take the factors of 18 that add to 9. So 1 and 18, 2 and 9. Oh, there's a 9, but they don't add, and 3 and 6. This is a positive 18, so these have to be the same sign. In adding to 9, we didn't need a negative 3 and a negative 6. All right, that'll do it. Number 33. M cubed minus 216. Is there a greatest common factor? There is not. And we are in 2 terms, so we're difference of squares or sum or difference of cubes. And we see this is a perfect cube. And 216 is 6 cubed as well, so we are a difference of cubes. So we're going to start out here just like number 31. M minus 6, and then m squared. And there's a plus 36 on that end. And the magic middle is the opposite sign, plus 6 times m. There we have it. All right, number 34. Greatest common factor? Nope. 2 terms, difference of squares or difference of sum or difference of cubes. We're at a difference. 64 is a perfect square, but that's a perfect cube. Oh, 64 is a perfect cube as well. Yeah, this is t cubed minus 4 cubed, so t minus 4, 31, 33, and 34, all the same type of problem. T squared plus a 16 over here, and the magic middle is the opposite sign, positive 4 times t. You can try to factor that out again, but again, nothing times to 16 and adds to 4. Good. All right, number 35. Is there a greatest common factor? There is, 9x and x minus 2. That's it for that one. That was nice. And the last one, we have 729 q cubed plus 1,000. Is there a greatest common factor? This is just 10s, 2s, and 5s. No 2s and no 5s, no 10s go into that. So no greatest common factor. There are 2 terms, and there's a plus sign, so we better hope it's a sum of cubes. And yes, this is indeed 9 cubed, so that's 9q cubed plus 10 cubed. So that tells us we're going to do 9q plus 10. And this squared, 81q squared. And on the far side is going to be plus 10 squared, which is 100. That'll ensure that we get 9q cubed and 10 cubed. And the magic middle is the opposite sign of 9q times 10, which is 90q. Oh, we had quite a few difference of cubes there, sum of cubes. We had 4 of them. And there we go.